Here are some practice questions from old regions. Let's see how we do. The first question asks which substance cannot be broken down by a chemical change. Well, we know that the only type of substance that can be broken down by a chemical change is a compound, and the type of substance that cannot be broken down at all is called an element. So in this case, we're looking for an element. Now we know that all the elements are on our periodic table of elements, but not all of us know all of the symbols, so instead we should look at table S. Taking a look here on reference table S, you'll find the names of all the elements that you are expected to know are elements. When we look here, we can find zirconium as element number 40. All of the other items are not listed anywhere on reference table S, so those are not elements you're responsible for knowing. So they actually are not elements, they are compounds. So here, the correct answer is zirconium. The next question simply asks which particle has no charge. Remember, no charge means neutral, so that is a neutron. The next two questions were kind of the same question, but it asks what is the charge of the nucleus of an oxygen atom. So here the key word is nucleus. We know that in a nucleus we have protons and neutrons. The protons have a positive charge while the neutrons have no charge. So in an oxygen atom, we can see here from reference table S that oxygen has an atomic number of 8. So it has 8 protons, giving it a positive 8 charge. Remember, the overall atom has a neutral charge of 0, but in the nucleus it's always the positive charge equal to the atomic number. The next question asks what is the mass number? Remember that the mass number is the protons plus the neutrons of a carbon atom with 6 protons and 8 neutrons. The electrons have no mass, so they are not counted in the mass number, so 14 is our best answer. In the next question, we're given an isotope symbol for iron 57. We can see that the protons and the neutrons are equal to 57, while the protons by themselves are equal to 26. To determine how many neutrons, we simply have to subtract. That gives us 31 neutrons. The next question asks us about a germanium atom. Germanium can be found on reference table S. You can see here that germanium is element number 32. From here, it is best to proceed by looking at your reference table. Here we have the block from the periodic table of germanium, element number 32. The question asks us to find the valence electrons. The valence electrons are the outermost electrons. So to find the valence electrons, simply look to the rightmost number in the electron configuration. Germanium has a valence of 4. Now the final question in this column asks us to find the net or total charge of an ion that has 8 protons, 9 neutrons, and 10 electrons. So what we want to do is write down the information given. Again, we have 8 protons, 9 neutrons, and 10 electrons. We'll multiply each of the numbers given by the charge that we know for each subatomic particle. Protons have a charge of +1. Neutrons have no charge, so we'll say 0. And electrons have a -1 charge. When I multiply these numbers out and add them together, I get that this ion must have a total charge of -2. Now let's look at the last 3 questions. Question number 9 asks, what are the total number of electrons in a magnesium ion? So here we have to use some of the information we are given and some of the information from the periodic table to determine the charge. Here we have the cell block from the periodic table showing us magnesium. Notice that in the cell block they give the information of the atom to the left and the possible charges of ions to the right. Remember, unless the symbol indicates it's an ion, as is indicated in this question, we will always assume that we have an atom. Now, when we look at the atom of magnesium, we see the electron configuration indicates that we have 2, 8, and 2 electrons. That means we have a total of 12 electrons. But the ion has a charge of +2. Remember that the charge is equal to the number of protons minus electrons. All magnesium symbols always go along with 12 protons. We're looking for the electrons, so we'll just call them E for now. Remember that the question has already indicated the charge. The charge is +2. If we solve this algebraic equation, we'll find that the number of electrons is equal to 10. Remember, since electrons have a negative charge, ions that are positive have lost their negative electrons, and ions that are negative have gained their negative electrons. Now let's try this again, looking at the sulfur ion. Pause the video now to see if you can determine the number of electrons in a sulfur 2- ion. Remember that 2- is the same thing as -2. Okay, for this sulfur ion, again, we have the charge is the number of protons minus the number of electrons. Every sulfur atom has 16 protons. We're unsure of the electron number, so we'll just leave it as a variable. And the charge is indicated as -2 or 2-. When we solve this, we see that a sulfur ion has 18 electrons. The final question asks us to determine which two atoms represent isotopes of the same element. Remember, if we have the same element, we must have the same number of protons. That means that the only two elements that are the same here are the elements with 9 protons. Now these are indeed isotopes because they have the same number of protons but different number of neutrons. This concludes part 1 of Test 1 review. Do look for the additional videos to continue your review.